proceed. 5.4, number 1. 5.4 talks about multiplying polynomials instead of adding and subtracting. We'll start off with a one-term polynomial called a monomial. So it'll be a coefficient times the power of x. Now that times another coefficient times another power of x. Ax to the n plus bx to the m. The coefficient is a times b. But for x to the n times x to the m, we add the powers. So we multiply coefficients and add powers. So for example, 2a to the second plus 3a to the fifth. Well, coefficient is 2 times 3. The power is 2 plus 5. So you get 6, a to the 7th. And here we have more than one variable. We just add different powers in different variables. So 1/6 g to the 4th h third times 36 g to the 7th h 11. Or the coefficients are 1/6 and 36. We multiply them here. G has powers 4 and 7. So you get g to the power 4 plus 7. H has powers 5 and 11. So you get h to the power 5 plus 11. 1/6 of 36 is 6. 4 plus 7 is 11. 5 plus 11 is 16. So 6 g to the 11th, h to the 16. Now here's an even gnarly one. 3 of them multiplied together with 3 variables each. Oh my goodness. Coefficients are 2, 4, and negative 5. 2 times 4 times negative 5. That comes out to negative 40. H to the second, h to the first, be careful, and no x's at all. H to the second times h to the first, you add the 2 and the 1 and get x to the third. Y to the third, y to the fifth, y to the sixth. Add 3 plus 5 plus 6, get 14, y to the power 14. Z to the fifth, z to the first, z to the sixth. Z5, Z1, Z6, add the powers and get 12. So negative 40, x to the third, y to the 14th, z to the 12th. Now, if we want a monomial times a polynomial, then we distribute. A times b plus c plus d plus e all the way up to z is ab plus ac plus ad all the way up to az. So here we have, for example, 2x squared times 5x cubed minus 4x squared plus 7x minus 11. So what we'll do is we'll multiply 2x squared times each one of these 4 terms. So this times the first is 2x squared times 5x cubed. This times this is 2x squared times minus 4x squared. This times this is 2x squared times 7x. And this times this is 2x squared times minus 11. Okay, after multiplying coefficients and adding powers, you get from here 2 times 5 is 10, 2 plus 3 is 5, 10x to the fifth. 2 times negative 4 is negative 8, 2 plus 2 is 4, minus 8x to the fourth. 2 times 7 is 14, x squared times x to the first. There's always that invisible 1 here. That'll be x to the third, 14x third. And 2x squared times negative 11 is minus 22x squared. So this. Now, all right, I really, in retrospect, I think I should have added in this section here, right here, think about FOIL, first, outer, inner, last, but I'm pretty sure you're familiar with that. And okay, there's some special products. The square of a sum, the square of a difference, and a sum times a difference. Square of the sum, you get a squared plus 2ab plus b squared. Square of the difference is a squared minus 2ab plus e squared. A sum times a difference is a difference of squares. So for example, 2a plus b all squared, well, the square of 2a is 4a squared. Oh dear, honk me again. This should be a 4 rather than a 2ab. Okay, I get honked for that. Then plus a b squared. Here, similarly, it's 4a squared. Then this should also be a minus 4ab. 5, 2, 1. 5, 4, 2, 1. 2, 1. Minus, plus, minus 4ab. Most unfortunate. All right, then sum times a difference would be a difference of squares. Square of 2a is 4a squared minus b squared. polynomial times a polynomial. So here we're going to use long multiplication, sort of like grade school multiplication, only you don't have to do borrow or carry. So here we go. 2y squared plus 3y plus 2. That times 3y plus 1. First, I'll multiply 1 times each of these. Oh, dear. Oh, dear. I am making so many mistakes here. This should be a 2. I'm really apologizing for this. 5, 4, 3, plus 3y, plus 2. I don't know how that happened. All right. No, it's... I think this 2 and this 1 are switched around. This is most... You know what? This is a complete botch. This should be a 2. This should be a 3. That one should be completely changed. Honkity honk. Oh, dear. This one's a little bit better. Y squared plus xy. I definitely should make a marker point off from me for that. Y squared plus xy plus y squared times x minus y. Okay, y times this is a minus y cubed. Y times this is a minus xy squared. Y times this should be a minus xy squared. Lots of errors in this. I'm very sorry. And x times this is xy squared. X times this should be a plus x squared y. This times this is x cubed. After a bunch of adding, you get x cubed minus y cubed. Right answer, but some mistakes here and here. Here and here specifically. Ugh. All right, we proceed. Where was I? All right, some examples. 7t minus 2 times 2t plus 3. We'll use FOIL. 7t times 2t, that's the first, is 14t squared. Outer is 7t times 3, that's 21t. Inner, minus 2 times 2t is minus 4t. And last is minus 2 times 3 is a minus 6. Now, here are two like terms, 21t minus 4t, which comes out to 17t. So in the end, you get 14t squared plus 17t minus 6. Here we have 3y cubed minus 4 times 2y cubed minus 1. What is that? Again, we use FOIL. First, 3y cubed times 2y cubed is 6y to the 6th. Outer, 3y cubed times minus 1 is minus 3y cubed. Inner, minus 4 times 2y cubed is minus 8y cubed. And last is minus 4 times minus 1 is plus 4. So 6y to the 6th, these add up to minus 11y cubed plus 4. I have a 1/4 b, all that minus 2, all that squared. Now this is a square of a difference. So you get square minus twice product plus square. 1/4 of b, square that, minus twice 1/4 of b times 2, and plus the square of 2. 1/4 b all squared is 1/16 b squared. Here the 2 and the 2 and the 4 cancel, leaving a minus b, and 2 squared is 4. 1/16 b squared minus b plus 4. Now here we have a difference times a sum. X squared y minus 6/5 plus 6/5. A difference times a sum is a difference of squares. So we square x squared y, subtract square of 6/5. So this comes out to x to the 4th y squared minus 36 over 25. Now here they just asked to, 111a and b, we have the same two polynomials. Here we add them, here we multiply them. 2x squared plus 5 and 3x squared plus 2x plus 1. Now we add like terms. 2x squared plus 3x squared is 5x squared. 2x is alone here, so plus 2x. 5 plus 1 makes 6. 3x squared plus 2x plus 6. Now here we're going to multiply them. 2x squared plus 5 times 3x squared plus 2x plus 1. So I do it vertically. 3x squared plus 2x plus 1 here. 2x squared plus 5 here. We leave a gap where there's no x term. 5 times each of these. 5 times 1 is 5. 5 times 2x is 10x. 5 times 3x squared is 15x squared. This times each of these. 2x squared times 1 is 2x squared. 2x squared times 2x is 4x cubed. 2x squared times 3x squared is 6x to the fourth. Now we add them all up. This is the one where this is the only long column where they all actually have something that happens. 5, 15, and 2 makes 17. The rest just carry down. So 6x to the fourth plus 4x cubed plus 17x squared plus 10x plus 5. And here they have a word problem where there's a rug, which is 36 by 46 inches, but there's a margin of X inches around the center. So what's the area of this part inside the margins? Okay, this is 36, but we subtract X here and here. So that's 36 minus 2X is this side. This side here is a 46 minus X, so that's 46 minus 2X. So the area is this length times this length. 46 minus 2X times 36 minus 2X. Okay, and this is the case for FOIL. 46 times 36 is 1656. Outer is 46 times minus 2X, that's minus 92X. Inner is minus 2X times 36 is minus 72X. And last is minus 2X times minus 2X is plus 4X squared. All that's left here is that we add these two like terms. And minus 92X minus 72X is minus 164X. So the upshot is 1656 minus 164X plus 4X squared. All right, I believe we have finished the section.